A patient reaches for a shirt with the left hand. Then the right hand slaps the left hand away, choosing a different shirt. This is not a joke. It is the reality following a complete severing of the corpus callosum, the massive bundle of nerve fibers connecting the two cerebral hemispheres. This radical neurosurgical procedure, called a commissurotomy, was historically performed to contain severe, life-threatening epilepsy that resisted medication. The result is a brain where the two halves operate largely independently, creating two distinct fields of consciousness within a single skull. These experiments provide the most compelling empirical evidence that the unified self we experience is an illusion, a constructed narrative masking a duality of minds. The corpus callosum consists of approximately 200 million axonal projections, serving as the primary communication bridge between the left and right hemispheres. In cases of intractable epilepsy, seizures often propagate rapidly across this bridge, leading to generalized, debilitating convulsions. By surgically cutting the corpus callosum, a procedure known as callosotomy or commissurotomy, the electrical storm is confined to one hemisphere, significantly reducing seizure severity and frequency. While the procedure successfully treats the epilepsy, it eliminates the instantaneous, seamless transfer of information between the two halves of the brain. This physical separation allows researchers to isolate cognitive functions and test the independent capabilities of each hemisphere. Roger Sperry and his student Michael Gazzaniga pioneered the systematic study of these split-brain patients starting in the 1960s. Their methodology involved presenting sensory information exclusively to one hemisphere, exploiting the contralateral organization of the nervous system. Sperry's work demonstrated that the two hemispheres possess specialized, distinct cognitive abilities, confirming the principle of lateralization. This research earned Sperry the Nobel Prize in Physiology or Medicine in 1981. Crucially, the experiments showed that while the hemispheres were disconnected, the patients appeared outwardly normal in everyday life, suggesting that the brain possesses powerful compensatory mechanisms to maintain behavioral coherence. To ensure information reaches only one hemisphere, researchers utilize a tachyscope, flashing images or words for milliseconds, too quickly for the patient's eyes to move. Information presented to the right visual field is processed exclusively by the left hemisphere, which typically contains the language centers. Conversely, information presented to the left visual field is processed by the right hemisphere. If the word key is flashed to the right visual field, the patient can verbally report seeing the word. If the word key is flashed to the left visual field, the patient reports seeing nothing, because the right hemisphere cannot transfer the linguistic information to the left hemisphere for verbal articulation. Although the right hemisphere cannot speak, it is not unconscious. It retains sophisticated cognitive abilities, particularly in spatial reasoning, facial recognition, and emotional processing. When the word key is flashed to the left visual field, the patient cannot say the word, but they can correctly select a key from a hidden array of objects using their left hand, which is controlled by the right hemisphere. This demonstrates that the right hemisphere perceived and understood the command, yet the left hemisphere, the source of verbal self-report, remains completely unaware of the perception or the subsequent action. The right hemisphere is conscious, but linguistically mute.
When the left hemisphere receives information that the right hemisphere acted upon, it immediately generates a plausible, yet entirely false, explanation for the action. This phenomenon, termed confabulation, reveals the left brain's role as the interpreter. For example, if the right brain is instructed visually to stand up, the left brain, unaware of the instruction, will invent a reason, perhaps stating, "I felt thirsty and wanted a drink." The interpreter module constantly seeks causal explanations for behavior, even when the true cause is inaccessible to it, maintaining the illusion of a coherent, rational self. This mechanism is believed to operate constantly in all human brains. Emotional stimuli can also be isolated. If a frightening image is shown only to the right hemisphere, the patient reports seeing nothing but exhibits physiological signs of distress, such as increased heart rate. When asked why they feel anxious, the left hemisphere interpreter might invent a reason, such as, "I don't like this room." In rare instances, the lack of communication leads to direct conflict, sometimes called alien hand syndrome. The left hand, controlled by the right hemisphere, might attempt to undo actions performed by the right hand, such as closing a book the right hand just opened. This physical manifestation of internal disagreement underscores the separation of executive control. The split brain findings fundamentally challenge the traditional philosophical and religious concept of a single, indivisible soul or self. If consciousness can be cleanly divided into two separate, often conflicting streams of awareness, the notion of a unitary, non-physical entity governing the body becomes untenable. The evidence suggests that consciousness is not a singular entity, but rather an emergent property arising from the complex, integrated functioning of specialized neural modules. When the integration mechanism, the corpus callosum, is removed, the unified self dissolves into its component parts, demonstrating its biological dependence. Secular humanism relies on empirical evidence and naturalistic explanations for understanding human existence, and the split brain data strongly supports this framework. Consciousness is understood not as a supernatural endowment, but as a biological phenomenon, a product of the brain's architecture. The interpreter module illustrates how the brain constructs a continuous, rational narrative to ensure social coherence and predictability, even if that narrative is factually inaccurate. This construction of self is a survival mechanism, not a reflection of metaphysical truth. Understanding the self as a collection of specialized, sometimes competing systems allows for a more accurate, evidence-based view of human agency. The interpreter's tendency to confabulate reasons for actions initiated unconsciously or by the separate hemisphere raises profound questions about free will. If our conscious verbal self only rationalizes actions after they have been executed by non-conscious or isolated modules, then the feeling of conscious choice may often be retrospective justification rather than causal initiation. The split brain experiment suggests that agency is distributed and often determined by underlying neural processes inaccessible to the verbal self. This shift from a singular, freely willing agent to a complex, modular system is a cornerstone of modern naturalistic philosophy of mind.